Continuing our discussion on the systems used for word sense disambiguation, we have seen supervised systems and unsupervised systems. And in this class, we'll be talking about another unsupervised system which deals with multilingual settings. This algorithm is known as Salaam algorithm, sense assignment leveraging alignment and multilinguality, SALAAM, Salaam algorithm. So this is used in multilingual setting when we want to disambiguate a certain words in a particular language. The basic technique here is we can convert those words into another language, and the ambiguity may be resolved in that second language, and we can propagate that sense into the first language. For example, we have been talking about bank. So in English language, bank has prominently two senses. In one sense, it is a financial institution where we deposit the money and withdraw the money, financial bank. And in another sense, it is a river bank or a pond near water resources. So there is an ambiguity in English language. But when we convert that sentence into Telugu, in Telugu, financial institution, we call it as a bank, and the river bank is not called bank in Telugu. In Telugu, it is called Thiramu or Oddu. So when we convert those sentences into Telugu language, the ambiguity will be resolved very easily. So this Salaam algorithm, let us see step by step what is this sense assignment, leveraging, alignment, and multilinguality algorithm. The first step is you have two languages, L1 and L2, and we want to cluster the words into in L1. So the source language is L1 and the target language is L2. So L1 words that translate into the same L2 words are grouped into clusters. For example, in English L1 and Arabic L2, the word plant. Plant may have two senses in English. One may be industrial plant, the plant running, and another one is a living organism, a small plant, sapling. But in Arabic, when it is translated, they don't have a common word, but they have for industry, they have Mahatta, and living organism is Nabat. Even in Telugu, when we talk about plant in industrial sense, we use Parisrama. Whereas when we talk about plant in living organism, we use the word Mokka. So when we translate those sentences into other language, the ambiguity will be resolved. So by examining translations, we create clusters of words that align with the same L2 word. So second step, this is the first step, grouping L1 words into clusters. Then the second step is sense identification using Salaam. So Salaam identifies appropriate senses for the words in those clusters using WordNet. It measures the proximity of word sense. In the last class, we have seen about how we measure the proximity or the distance. And Resnick has proposed a semantic similarity measure known as information content, which is logarithm of the probability of the occurrence of the words. And high similarity means the words are very closely related in the meaning. Then the third one, among the available senses, we have to select the sense. Suppose plant, whether we have to select industrial sense or whether we have to take biological sense. So that criteria is applied to choose the appropriate sense label or set of sense labels for each word in the cluster. The criteria ensures that each word in the cluster is assigned the most accurate sense based on the proximity calculation to other words in the cluster. And the fourth step is once we choose the sense tag, propagating it to the original language, the selected sense tags for the words in cluster are propagated back to their respective context in the parallel text. So simultaneously, Salaam projects the propagated sense tags for L1 words onto their L2 corresponding translations. This step will allow the algorithm to label words accurately across the different languages. This is Salaam algorithm.